Welcome to Outbreak Brief, the podcast that takes you inside the world's most dangerous infections. Today, we are looking at a microscopic force that can completely hijack your body with as few as 10 single cells.
Yeah, it really is astonishing when you look at the numbers. I mean, the threshold for this infection is just incredibly low.
Right, because normally, with most foodborne pathogens, you have to swallow hundreds of thousands or sometimes millions of bacteria before you feel even slightly sick.
Exactly. Our bodies encounter millions of bacteria every single day and, pretty much just shrug them off. But the pathogen we are diving into today, Shigella, it requires almost zero critical mass to launch a full-scale invasion.
Okay, so let's unpack this. When you look at the detailed medical sources we have today, we're talking clinical overviews from stat pearls and public health data straight from the CDC, that infectious dose of 10 to 100 organisms just jumps right off the page.
It does. It's practically nothing. 10 bacteria is an amount that could easily just reside on an invisible speck of dust or, in a microscopic droplet of water.
Wow. So to understand why such a tiny amount of bacteria is so dangerous, we need to know what we are actually dealing with here. What is Shigella?
Well, scientifically speaking, it's categorized as a gram-negative facultative anaerobic bacillus.
Okay, hold on. Let's translate that out of textbook speak for everyone listening.
Right, yeah. So bacillus just means it's a rod-shaped bacterium. And facultative anaerobic is a fancy way of saying it's highly adaptable. It can survive and multiply whether it has oxygen or not.
But the gram-negative part is the real issue, right?
Exactly. Gram-negative bacteria have this built-in armored outer membrane. You can think of it like a castle with an extra outer wall, which inherently protects them from a lot of our standard antibiotics.
And it's not just one single type of bacteria. The sources divide this genus into 4 distinct species, or serogroups.
Yeah, 4 different faces of the same villain. And rather than thinking of them as a crime syndicate, I think it's more accurate to look at these 4 strains as different types of military invasions. Each has its own strategy and threat level.
Okay, so walk us through the ranks. Who's first?
First up is Shigella sone. This is the most common one you'll find in the United States and other high-income countries.
So if that's a military action, what kind of attack is it?
It's essentially a quick border skirmish. It gets in, causes localized chaos, but it usually doesn't dig incredibly deep into the tissue. The immune system generally forces it to retreat.
So that's the one causing mild or watery diarrhea. It's highly contagious, but usually clears up on its own.
Right. But the next one changes the game completely. That's Shigella flexneri. This is the most common strain globally, highly endemic in low and middle income countries.
And this isn't just a border skirmish anymore.
No, not at all. This is a protracted ground invasion. S. flexneri digs much deeper into the intestinal tissue, which is why it's notorious for causing bloody dysentery. It actively destroys the landscape as it moves.
Geez. And the third one?
That's Shigella boydii, which acts more like a regional force. It's relatively rare globally, but remains firmly entrenched in specific parts of Africa and South Asia.
Okay, but then the clinical data outlines a 4th strain that just sounds utterly terrifying. Shigella dysenteriae.
Yeah, specifically type 1. If the others are ground troops, S. dysenteriae is a scorched earth campaign dropping chemical weapons.
Wow, chemical weapons.
I mean, it literally. This species produces the devastating Shiga toxin. It has a high mortality rate and is infamous for sparking massive epidemics, especially in populations facing, war, natural disasters, or places where the sanitation systems have completely collapsed.
So it strikes when humanity is already at its most vulnerable.
Exactly. Throughout history, whenever you see massive human upheaval and crowded, unsanitary conditions, Shigella dysenteriae is right there weaponizing the body against itself.
Wait, I want to back up a second, though. You mentioned that they have this gram-negative armor.
Yeah.
But if we are talking about an invading force of maybe 50 bacteria, how are they taking down a human host? Because stomach acid should just melt them on contact.
Usually, yes. Most bacteria you swallow are instantly destroyed by human stomach acid. It's our primary chemical moat.
Right, it's highly acidic.
But Shigella is uniquely acid resistant. It essentially wears a chemical spacesuit, so that tiny little inoculum of 10 to 100 bacteria just floats right through the acid bath, completely unharmed.
Unbelievable. Okay, so they survive the stomach and reach their target destination, which is the colon. What exactly is the mechanism of spread once they get there?
Well, they don't just sit on the surface. They actively cross the mucosal membranes of your intestine. And to do this, they target these specific things called M cells.
M cells, what do those do?
Think of M cells as the border guards of your gut. Their normal job is to just sort of sample the environment, pull tiny particles inside, and hand them over to the immune system to check for danger.
Yeah.
So Shigella uses a process called transcytosis to deliberately get caught by these guards.
Wait, so instead of breaking in, they intentionally trick the body's own security cells into pulling them inside the fortress.
It is the ultimate Trojan horse strategy. The M cells pull them through the barrier and hand them right to the immune system's macrophages.
And macrophages are those massive white blood cells, right?
Yeah.
Like the cellular garbage disposal.
Exactly. Their entire biological purpose is to swallow and digest foreign invaders.
But I'm guessing, since we get so sick, the macrophage doesn't actually digest the Shigella.
Far from it. Once it's inside the macrophage's internal stomach, a compartment we call the phagosome, the bacteria breaks out. It escapes into the main body of the immune cell.
Oh, man.
And then it triggers the macrophage to undergo apoptosis, which is programmed cell death.
So it literally forces the immune cell to commit suicide.
Yes. And what's fascinating and terrible is how the pathogen uses our own immune response to destroy the gut barrier. When that macrophage dies, it doesn't just quietly fade away.
It makes a scene.
A huge scene. It unleashes a massive wave of inflammatory cytokines, specifically things called interleukin-1 and 8.
The sources drop those terms a lot. In plain language, what do interleukins actually do?
Think of them as chemical flare guns. The dying cell shoots thousands of these flares into the surrounding tissue, just screaming that the body is under attack.
Which brings in more immune cells, I assume.
Right, it summons an aggressive wave of reinforcements, but the resulting crossfire is so intense that the severe inflammation begins to tear apart the gut tissue from the inside out.
So it tricks the guards into blowing up the wall from the inside.
Exactly. And once that wall is compromised, Shigella invades the structural cells that line the intestines, called enterocytes. They multiply inside them, hijack the cell's machinery to propel themselves to the next cell, and start releasing enterotoxins.
Like She-OET1 and She-Q2, which the clinical texts mention.
Yeah. And these toxins act like microscopic drills. They disrupt the normal fluid balance, causing cells to leak massive amounts of water into the gut. That's what causes the severe watery diarrhea.
But with the more aggressive strains, it gets worse than just water, right?
Yeah, the physical destruction of the cells causes the intestinal lining to literally ulcerate, die, and bleed.
Which brings us to what the person's actually going through. I mean, this microscopic warfare translates into very real physical suffering. So who is most at risk here, and what does this infection actually look like?
Well, let's talk about the symptoms first. The incubation period is incredibly short, usually just 1 to 4 days after swallowing the bacteria.
That's fast.
Very fast. And it starts with a sudden high fever and severe stomach cramping. We are talking diffuse, colicky, doubling over kind of pain.
And then the dysentery starts.
Right. Small volume diarrhea that contains visible blood and mucus because the cells are literally bleeding into the digestive tract. But there's another symptom highlighted in the clinical data that sounds like pure misery. It's called tenesmus.
Tenesmus, what is that?
It's the constant urgent feeling of needing to pass stool even when the bowels are completely empty. It happens because the rectum is so inflamed and ulcerated.
So the nerves are just completely overwhelmed.
Exactly. They are constantly firing emergency signals to the brain that the bowel is full and needs emptying immediately.
It's like your body's fire alarm is glued in the on position, even when there's no smoke left in the building. You're just trapped listening to it ring.
That's a perfect way to describe it. And the constant straining physically exhausts the patient, compounding the dehydration.
But the risks don't stop at the bathroom door, do they? If the gut is being shredded, it has to affect the rest of the body.
Oh, absolutely. It causes systemic chaos. For instance, generalized febrile seizures are a known complication, particularly in young children.
Wait, seizures? From a stomach bug?
Yeah, the leading theory is that the extreme spike in fever, combined with the severe electrolyte imbalance from the diarrhea, sort of temporarily shorts out the neurological electrical activity.
That is terrifying for a parent. And the sources also mention something called hemolytic uremic syndrome, or HUS.
Yes, and this is the most dangerous systemic threat, primarily associated with the Shiga toxin from S. dysenteria. If that toxin crosses from the gut into the bloodstream, it actively shreds your red blood cells.
Like shattered glass in the bloodstream.
And those shattered cell fragments get swept into the kidneys, which act as the body's filters. The microscopic debris clogs those delicate filters, leading to acute kidney failure. It has a very high mortality rate.
And there's also a structural risk to the colon itself.
Right.
Toxic megacolon.
Right. The inflammation can become so severe that the colon's muscle layers become paralyzed. It rapidly widens, trapping gas and feces, and if it expands too much, the bowel can actually tear open.
Which spills highly infectious contents directly into the abdomen.
Exactly. It's an immediate, life-threatening emergency requiring surgery.
Even if you survive all that, the texts mention lingering effects like reactive arthritis. How does a stomach bug give you arthritis months later?
It happens through molecular mimicry. When your immune system fights off Shigella, it creates customized antibodies. But unfortunately, some of the proteins in your natural joint tissue look incredibly similar to those bacterial proteins.
Oh no, so the immune system gets confused.
It's friendly fire. Long after the bacteria is gone, your antibodies patrol your body, find your joints, think they see Shigella, and attack. It causes a sterile, incredibly painful joint inflammation that can last for months or years.
So if the complications are this severe, it feels like there should be a rush to the ER and demand the strongest drugs situation. But treating this is actually walking through a minefield. What are the treatment options?
For mild cases, the golden rule is simply aggressive hydration. You just have to endure it and meticulously replace the fluids and electrolytes for 5 to 7 days.
But if I have severe diarrhea, my first instinct is to take an over-the-counter anti-diarrhea medicine like loperamide. Why do the sources explicitly warn against this?
Anti-motility drugs are strictly contraindicated. It seems counterintuitive, but slowing down the gut is the absolute worst thing you can do.
Because the diarrhea is trying to flush it out.
Exactly. It's a mechanical flush. If you take a drug that paralyzes the bowel to stop the diarrhea, you are trapping the Shigella inside.
You essentially lock the criminals inside the bank vault and give them more time to drill into the safe.
By trapping them, they multiply further, driving the enterotoxins deeper into the tissue, dramatically worsening the ulceration and increasing the risk of that deadly toxic megacolon.
Okay, so no anti-diarrhea meds. What about antibiotics?
For severe or hospitalized cases, we do use antibiotics like fluoroquinolones, azithromycin, or third-generation cephalosporins. But here is where the public health data gets truly alarming.
The rise of superbugs.
Yes, extensive drug resistance, or XDR. Shigella is rapidly learning how to defeat our best, most advanced antibiotics.
How is it learning so fast, though? Evolution's usually a really slow process.
Well, they aren't just mutating in isolation, they are sharing resistance actively, like open source code on a computer network. This happens through horizontal gene transfer using things called plasmids.
Explain plasmids for me.
Plasmids are mobile, circular pieces of DNA that exist independently of the bacteria's main chromosome. Think of them as genetic USB drives. Bacteria can physically connect and pass copies of these USB drives to each other.
And these USB drives contain the blueprints for defeating our drugs.
Let's look at one example from the whole genome sequencing data. The BLAST TTXM27 gene. This gene is carried on a plasmid, and it produces an enzyme that acts like a biological shield, destroying cephalosporin antibiotics before they can even work.
And Shigella can just hand this shield to its neighbors.
It can hand it to other Shigella, or even entirely different types of bacteria in your gut. It renders our first-line defenses completely useless.
Are there any vaccines available? I mean, with the threat this severe, where are we with immunity?
There is currently no widely available approved vaccine for Shigella. There are some in the research pipeline, but for now we have to rely purely on natural defenses and, more importantly, infection control.
Which brings us to prevention. Since relying on antibiotics is becoming a losing battle, and we don't have a vaccine, the best strategy is making sure it never gets past your lips. How exactly is it spreading, and who is catching it?
Well, humans are the ultimate and only natural reservoir for Shigella. It doesn't live in soil or farm animals, it lives in us. And it spreads entirely through the fecal-oral route.
And with an infectious dose of just 10 bacteria, a microscopic trace is enough to cause an outbreak.
Exactly. Which is why children under 5 are the most vulnerable population. They account for a massive portion of the 188 million global cases.
Right, because if you drop your toddler off at daycare and just one toy or changing table has a microscopic trace on it.
That entire facility is a hotbed by noon. Toddlers put everything in their mouths. Early education centers are primary vectors.
Who else is at high risk?
International travelers, especially those visiting regions without treated water, they are at higher risk of encountering severe strains and picking up those highly drug-resistant plasmids to carry home.
And the data also highlights another demographic tying back to those XDR strains, right?
Yes, men who have sex with men, or MSM. Public health surveillance shows a rapid global rise in sexually transmitted Shigella within this demographic. Any sexual contact involving potential fecal exposure carries an exceptionally high risk of transmission, and these outbreaks are frequently the extensively drug-resistant strains.
The sources also mention people experiencing homelessness and immunocompromised individuals facing severe risks. So, considering all this, what does prevention actually look like on an individual level?
The universal baseline is rigorous hand washing, not a quick splash of water. 20 seconds with soap and friction, especially after changing diapers or using the bathroom.
And if you're traveling, avoid raw vegetables, unpeeled fruits, and untreated water.
Also, avoid swallowing recreational water. Keep your mouth closed in lakes and community pools. But the most crucial timeline for prevention revolves around what you do after you recover.
Because you can still shed the bacteria, right?
Yes. People can shed the bacteria in their stool for up to 2 weeks after their symptoms have entirely resolved.
That has to be so psychologically difficult. You've been symptom-free for 5 days, you feel 100% healthy, and you want to go back to normal life.
But you are still a biological hazard. You must change your behavior for a full 14 days after your last bout of diarrhea.
So no preparing food for others.
No food prep. You must abstain from public swimming pools and splash pads. And crucially, you must abstain from all sexual contact for at least 2 full weeks after symptoms stop to prevent passing it on.
That discipline is absolutely non-negotiable given how easily this spreads.
Especially considering our diminishing treatment options.
Right. So where are we now globally?
We are in a state of high vigilance. Epidemiologists are heavily relying on whole genome sequencing to track these resistant plasmids as they jump from continent to continent, trying to stay one step ahead of the outbreaks.
Which leaves us looking toward the future. We've seen how this pathogen wears chemical armor, uses a Trojan horse strategy to force our immune cells to self-destruct, and causes agonizing symptoms from dysentery to kidney failure. But the most terrifying part might be what it's doing in the dark.
Yeah, and that's the final thought I'd encourage everyone to mull over regarding horizontal gene transfer. Think about your own gut right now. It's filled with millions of harmless, beneficial bacteria.
But Shigella operates like an open-source network.
Exactly. It freely shares its antibiotic-resistant blueprints with entirely different types of bacteria coexisting in your gut.
It's an arms bazaar right in our digestive tract.
If the bacteria in our microbiomes are actively trading the secrets of drug resistance, bypassing evolution entirely and just handing each other the code, are we rapidly approaching an era where a simple stomach bug inevitably becomes an untreatable systemic threat?
It's a sobering question, and one that makes those 20 seconds of hand washing seem a whole lot more profound. Stay informed, stay prepared. This has been Outbreak Brief.